So, 04 subfunction. Subfunction 04. So, what is the purpose of 04 subfunction? To retrieve a snapshot record, right? Yes or no? First thing, we need to understand what do you mean by snapshot record. Okay. So, when a DTC is logged, okay, when a DTC is triggered or raised, okay, raised means there will be fault condition detected by ECU, or we can say server. Server is running a test. When the server detected a fault condition and fault condition lasts for more than maturity time. Okay, let's say maturity time is 100 milliseconds. Then the DTC will be stored in server's memory, right? So let's say we'll take an example of voltage fault. Okay, let's say low voltage fault. Okay, and its DTC is 0 or 1, 2, 3, 4, 5. This is the 3 by DTC number. Okay, so and we'll take one more example. Let's say vehicle speed absent fault. Okay, this fault, when it will detect, when the node which is responsible to transmit vehicle speed CAN message is not sending for, let's say, 200 millisecond is the maturity time. Then this fault will log and DTC 78 minus EC. This is the DTC number which will be stored when this vehicle is speed absent fault is detected. Okay. Now we'll see how this absent fault first detect. So there is a voltage. Okay. And ECU is monitoring this voltage. So when the voltage is, let's say, 12 volt, okay, to 13.5, that is ideal voltage. So voltage was coming ideal. After some time, there was a fluctuation due to some reason, and voltage dropped to 8 volt. Okay. So then here the ECU will detect there is a low voltage fault condition happened. Understood, guys? There is a low voltage condition detected by the ECU. And when this low voltage continue for how much time? 100 millisecond. Let's say from here to here is 100 millisecond. Okay. So when this fault is detected and it lasts for more than 100 millisecond, then here at this point, DTC will be stored in the memory. Okay, this DTC. Understood, guys? Guys, have you understood here till this point? Am I audible?
Yes, sir.
Till here it's clear, right?
Yes, yes. Shall I repeat
Okay.
again? Sorry, repeat again.
Okay.
Once.
Yeah. I'll do that. See, this voltage is coming from external power supply, right? Power supply unit that is
Yes.
responsible for giving this voltage to the ECU. Okay.
Okay.
Now, ECU is running test. Means ECU will keep on monitoring what voltage is being received. Okay. So there may be a code running like if voltage received is within the range, let's say is greater than 9 and less than 16. Okay. Then consider test is pass. Means there is no fault detected.
Okay.
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 But if voltage received is less than 9 volts, okay, then check okay. I'll remove this. Check for timing. Like for how much time this fault. Okay. So there will be a timer. It will check whether this voltage is less than 9 for 100 millisecond or not.
Yes.
Okay. So when this condition came, that time this if statement will fail because voltage has detected less than 9. Okay. Now this condition will pass. The code is running here. Is voltage less than 9? Yes, because here voltage dropped to 8 volt. Then check, is it last for 100 millisecond or the timer is greater than 100 millisecond? So till now not greater, the timer will increment. Once it will reach here, then this condition satisfied, right?
Yes, sir.
This is also if low. Understood?
Yes, sir.
So this condition will satisfy.
Yes.
And here it will write DTC information in memory. Okay, it will call some function which will store this DTC into the memory. Along with this DTC, the status byte and the snapshot and extended data record also will be written in the memory. Okay, here only all the information will be written in the memory. This DTC number, what is the status of this DTC, the snapshot record, extended data record. Understood?
Yes, sir.
So
Yes, sir.
here only when the DTC is matured, all snapshot record, extended data record, DTC information, status wise, everything will be stored in the memory. Understood?
Yes, sir.
Like this, there will be another code running for vehicle speed. Okay. So this is one condition. I told now there will be millions lines of code. So this code is checking for voltage. Okay. Another piece of code is running if vehicle speed message received. Okay. Then test is passed. If vehicle speed message not received. Understood? So let's say this one understood, na? Voltage
Yes, sir.
wala.
Yes, sir.
Okay. Now we'll take another condition. Same like this only it will happen. Here ECU is detecting vehicle speed is received or not received. Okay. Understood? So based on that, how it will detect in the CAN there is transfer layer, right?
Yes, sir.
Transfer layer will detect whether the message is received or not, because validation is part of transfer layer, right? Understood now? So when a message is not detected, then it will trigger application layer. One variable will be there. Vehicle speed timeout fault. It will set it to true. Okay. So if the vehicle speed message not received, what will happen? Set vehicle speed fault variable to 1. Understood? It will set this vehicle speed fault variable to 1 and will check for timer. For how much time this message is not received. If this message is not received for 200 milliseconds, then it's write the DTC information related to vehicle speed in the memory. Understood? Guys?
Yes, sir.
Yes, sir.
Understood, na?
Yes, sir.
So just a minute. I will show it in the diagram of it. Okay. So ECU is running test. There will be multiple tests running for 600 fault. 600 if-else statements are written. Okay, whose responsibility is to check for fault condition. Test means what? Just checking in if-else statement. If voltage is less than 9 or not. Whatever the voltage received from external power supply, is it less than 9? Yes, then low voltage fault will be triggered. Understood? And when that fault stay for 100 milliseconds, then the DTC information will be stored in the memory. So which DTC? For low voltage fault, this DTC is mapped. So then in the ECU memory, this DTC will be stored. Along with that, snapshot record, extended data record also will be stored. Okay. So this voltage related thing is clear, right? Guys? Clear now? How the voltage check will be done by the ECU? Guys? Is it clear, right? Because the microcontroller can monitor voltage, right? External voltage, it can monitor whatever the voltage is received from the power supply. And based on that voltage monitor, there is an if-else statement that will decide whether low voltage, high voltage fault can be logged or it is normal voltage. If normal voltage, that means the test is passed. If ECU detects there is a low voltage or high voltage, then low voltage or high voltage fault will be first will be set to true. Then when the fault is matured, then DTC information which is attached with this fault will be stored in the memory.
Yes,
Clear?
sir. Yes, sir. Clear.
Yeah. Now if we'll talk about vehicle speed, what will happen? Now ECU is receiving message from CAN, right? Okay. So there is let's say there is a variable which is vehicle speed absent fault. Let's say this variable we have used in the ECU to capture is vehicle speed absent fault is present or not. And this depends on CAN. Any ID will set 0xA1. If the CAN of our ECU doesn't receive this message ID, then the CAN receiver, the transfer layer, will set this message was not received to the ECU application layer. Then this application layer will set this fault to true. Okay. If message is received, this will be 0. Okay. When the CAN trans receiver detected this vehicle speed is not received, this vehicle speed message is not received, then it will set this vehicle speed absent down to true. Understood? Guys, understood? Is it clear? See, there is CAN. Okay. CAN is responsible for validation. CAN is receiving all these messages. But there is a condition when our internal CAN, it doesn't detect this message. Okay. If it will not detect this message, CAN will tell our application layer issue application. Okay. Application layer, this message not detected. Understood? It will tell the application layer. Guys, able to understand now? When CAN will not detect this message, it will tell application layer this message is not detected. Then in the ECU, we have written code. If we have written code here, if message 0xA1 is not received, okay, then set vehicle speed absent equal to true. Understood? And not received, how will detect here? Because this information is sent by the CAN, maybe some variable. Okay. Variable name can be 0xA1 timeout flag. Okay. Or like this, it won't be. It will be timeout A1 message flag. Set this to. So here in the code, we'll check if this is true, then set this fault to true. And this is given by CAN. Okay. CAN is setting this to true and sending it to application layer. In application layer, we have written code. If this variable which is sent by CAN is true, then set vehicle speed absent fault to true. Understood? This variable will be set to true by CAN when it detects this message is not received. Guys, able to understand this? Yes or no? Guys?
No, sir. Sorry, repeat again. Sorry for that.
Okay. Okay, no problem. See, this CAN is detecting this fault. The transfer layer of CAN, it is responsible. See, CAN trans receiver is responsible for receiving CAN messages, right? Transmitting and receiving CAN messages. We discussed in CAN part, right?
Yes, sir.
Clear enough?
Yes, sir.
Okay. So CAN is responsible to receive and transmit messages.
Okay.
So in CAN is responsible to validate also. Okay. There, what it will do is, there are different messages and there are flags for each message. For that also we have written code. Okay. In the CAN BSW layer, we have written code. So what will happen if CAN detects this message received? So for this message, let's say periodicity is 20 milliseconds. So CAN is expecting every 20 milliseconds this message should be received. Clear? Is it clear?
Yes, sir. Yes, sir. Clear.
Because we have done configuration in the filter layer. Do you remember in CAN we have seen filter layer and algorithm we used to write local intelligent. Do you remember? So local intelligent is nothing but we are writing code for taking up. And filter is responsible for we are doing the configuration. If this message received, filter will pull that message and will send to local intelligent for processing. Okay. Local intelligent is nothing but there also we have written code. This message received, is it CRC okay? Is it rolling counter okay? Is DLC okay? If everything okay, then it will send everything okay to ECU. Understood? So now if this message received or not, we are using this flag to store. Okay. If CRC is correct or not, so checksum. Okay. A1 message error. Clock okay or not? Rolling counter A1 message error. Okay. DLC okay or not? DLC for A1 message error. These four variables are used in BSW layer to check whether the message timeout flag is set to true, whether the checksum received is error, whether the rolling counter is error, or whether the DLC is error or not. Okay. If this is received, then this will be set to 0. If checksum is correct, this will be set to 0 by the CAN BSW layer. Okay. And this all information will be sent by CAN to the application layer. Understood? Is it clear here? CAN is validating whether the message is received or not. Is there any timeout? No. Set it to 0. Is there a checksum error? No. Set it to 0. Is there rolling counter error? No. Set it to 0. Is DLC error? No. Set this error flag to 0. Send it all this flag to ECU application layer. Understood?
Yes, sir. It's clear.
Everyone, have you understood this? Guys? So now we know this A1 message is for CAN. Okay. Now let's say, okay. Now these flags are sent by CAN to the application layer. In application layer, we have written again code. Okay. If timeout A1 message flag is equal to 1, then set vehicle speed absent fault equal to true. Understood? Else vehicle speed absent fault will be 0. Is it clear? Is it clear? Guys, is it visible or not? Because the space is little less. Okay. Is it visible now? Guys, is it clear? Likewise, there will be other if-else statement which will check if checksum A1 message error is true, then set vehicle speed checksum fault to true. Understood? Else set checksum fault to false. Like this test will be running. Guys, have you understood?
Yes, sir.
Is it clear? Everyone? Likewise, these error flags are updated by the CAN to the application layer. In the application layer, we are running tests. Running test is nothing but writing code. If this flag, which is sent by the CAN, is true, that means detect as an absent fault. If checksum flag is error flag is true, detect as an checksum error or checksum fault. If rolling counter flag is set to true, detect as an rolling counter fault for vehicle speed. Understood? If the DLC error is detected as true by the CAN, then application will set vehicle speed DLC fault to true. Understood, guys? Yes or no?
Yes, sir. It's clear.
Clear now?
Yes, sir. Clear.
Okay. So now we'll see. Now, the CAN has detected there is an absent fault. Okay. Or it can be checksum fault, anything. CAN will send application layer, there is an absent fault or timeout detected for this message. Then ECU will write in the code, it's written, if vehicle speed A1 timeout error is set to true, then set vehicle speed absent fault to true. So when here the ECU application layer detected that error, timeout error for A1 message is true, it will immediately set this fault to true. Understood? And if this is true for 200 millisecond, okay, let's say this distance is 200 millisecond, then DTC information will be, this DTC related information will be stored in the memory. Guys, understood? So there can be possibility like this DTC, okay, this will be stored absent fault, vehicle speed, let's say checksum fault, vehicle speed rolling counter fault, vehicle speed PLC fault, and vehicle speed invalid fault. May be possible all these faults are linked with, these all faults are linked with one DTC, this DTC only. All these 5 faults, if any of these 5 faults are logged, this DTC will be triggered. I told, right, there are 500, 400 DTC, sorry, fault, but only 30 to 40 DTCs are there, right? So similar type of fault can be mapped with same DTC. So this is all related to vehicle speed CAN fault. So there is possibility all these vehicle speed same fault can be mapped with this DTC. So if vehicle speed absent fault is set to true and it stays for 200 millisecond, this DTC will be stored. Or vehicle speed checksum fault is set to true and that also stays for 200 milliseconds, then this DTC will be stored because this DTC is mapped with this fault also. Are you getting, guys? Guys, have you understood this? Please tell me, shall I repeat or have you understood? Understood, na? So when the fault is matured, here only all DTC related information will be stored in the memory. All the DTC related information will be stored in the memory. What are those? DTC number. Okay, this number. DTC, status of the DTC. Okay, snapshot, record, extended data record. All these information will be stored in the memory when this fault is matured. Is it clear, guys, till here? Everyone understood? Guys?
Yes, sir, clear.
What about others? What about others? Is it clear?
Yes, sir.
Okay.
Sir,
Good.
I have a doubt.
Sorry?
Hello. I have a doubt, sir. In extended snapshot data means what's the extended snapshot data?
Now I am coming to that point. Okay. Till here you
In,
understood now.
yes, sir. In
When
snapshot record data means information is stored in inside the DEM module, right?
sorry?
Information is stored in a DEM module, right? In a
Yes.
snapshot data.
See, DEM module that you are talking now.
Yeah.
There is diagnostic event manager.
Event manager,
Okay,
right?
DEM. So that will is stored, but there is a condition for it. Okay.
Okay.
Event manager is just responsible to set and the get data. Okay. Set data means all the data will be stored. It will call a function to store the data in the or write the data in the memory.
Okay.
Okay. Event manager is only for managing the event. Is it set event or get event? Writing the data or reading the data? Understood?
Okay, sir. Okay.
Okay, now?
Okay,
So
sir.
based on the condition, it will set event, then DEM module is there that will just write the data because there is a set event detected.
Okay.
Okay. So it will
Okay.
just stored the data, whichever the memory allocated for storing the DTC information.
Okay. Okay, sir. Thank you.
Clear now?
Yes, sir. Clear. It's clear.
Okay. So now we'll come to a snapshot record. What do you mean by a snapshot record? Okay. So till here clear, right? Once the fault is matured, then DTC information will be stored, all the related DTC information. Now we'll come to a snapshot record. Okay. Now we'll talk about low voltage fault or fine. This is there for vehicle speed absent fault. So we'll check for absent fault only. Okay. There is a DTC. This. Okay. For this DTC, we have two snapshot identification numbers attached. Okay. So snapshot identification number is nothing but, let's say one is 01, which will be stored, and another one is, let's say 02. This will be stored vehicle speed information. Okay. This will be stored, let's say column velocity information. Okay. This will be stored issue temperature information. This will be stored driver torque demand information. Okay. This will be stored, let's say, ECU current drawn. This will be stored, let's say, brake demand information. This will be stored, let's say, engine speed. And in snapshot 2, it will be stored, let's say, yaw rate. Okay, let's say in snapshot 1, these 4 parameters will be stored. These 4. Okay. In snapshot 2, these 4 parameters will be stored. Now, for this DTC, we have attached both. Okay. So for this DTC, this snapshot identification as well as this snapshot identification, both are attached. Okay. And if we'll talk about low voltage, only this snapshot was attached. Snapshot 2 was not attached for low voltage. Understood? So when we are doing the configuration, right, for each DTCs, we will do snapshot identification number, which is valid for this DTC. So we'll just do attach. There is a fixed snapshot information for each snapshot identification. Okay. There is a fixed snapshot for all snapshot identification. So 01 will always store these parameters. 02 will always store these parameters. Now, let's say for this DTC, I need to store only these parameters, sufficient enough for analysis. So I will not attach this. Okay. So only 01 will be attached to this DTC. But for this absent fault, I need to store both information. This also I need, this also I need. So for this DTC, I will attach this as well as this also. Is it clear? Guys?
It's clear.
Clear now?
Oh, yes, sir.
So for this DTC, I need to store this information as well as this both. So I have attached both. So when the fault is matured, at that time, this DTC will be stored in the memory. Status of this DTC will be stored as well as this and this both information. When this fault was matured, at that time, what is the vehicle speed? What was the ECU temperature? What was the ECU current? What was the engine speed? What was the column velocity? What was the driver torque? What was the brake demand? What was the yaw rate? Everything will be stored in the memory here. Understood? When the DTC information will be stored here, once this is mature, 200 millisecond. Here, all this data will take a snapshot, means whatever the value of this all parameter, it will take a snapshot, will store in the memory. At this time, what was the vehicle speed? What was the ECU temperature? If the vehicle speed is, let's say, 80 kilometer, okay? ECU temperature was 37 degrees C. ECU current was 1.5 ampere, let's say. Engine speed was 750 RPM. Column velocity was, let's say, 0.3 radian per second square. Driver torque demand, 20%, just driver, or 0%. Understood? Sorry. Brake demand, I told 0%. Driver torque demand, let's say 1 Newton meter. Okay. Brake demand is 0%. No brake was applied. Your rate was, let's say, 0.1 radian per second square. Understood?
Sir, I think one question, sir. These values are fixed or we are assigning some values randomly?
That what? At this
This
time.
vehicles information. Okay.
No. These are dynamic values, no? Vehicle speed, how it will be fixed? How the
Okay.
temperature will be fixed? How the current will be fixed? How the engine speed will be fixed? These all are dynamic
Okay. Okay. Sir.
values.
Okay.
Understood?
Okay, sir.
So when this DTC was triggered, what was the value of this dynamic parameter will be taken as a freeze frame. Means it will freeze the data stored in the memory. So once you'll read now, so when this fault was logged, what was the vehicle speed? It was 80. Now it can be 10, 20, 30, no problem. When this fault was matured, at that time, what was the vehicle speed? It was 80. What was the ECU temperature? Now ECU temperature can be 45, but that time when the fault was logged, at that time it was 37. Understood?
Yes, sir. Understood. Right.
Everyone understood? Everyone understood? Others, everyone clear? Guys, is it clear? Audible?
Yes, sir. You are audible. Your voice is clear.
Is it clear, right?
Yes, sir. It's clear.
This one, snapshot record?
Yes, sir.
Okay.
Right.
Yeah, now we'll see. Now using 19 service 04 subfunction, we want to read for which DTC we want to read the snapshot record. Let's say we want to read for this DTC 989ABC. So 789ABC. Client is sending, I want to read a snapshot record, that is 04. DTC mask is for this DTC. And which snapshot record, 01 or 02? So let's say 01. I want to read only this snapshot record, which is stored in the memory for this DTC. The client will send request 190478, the DTC number, and 01 snapshot record. If client want to read for 02, we'll send 02. If it want to read for all, then we'll send FF. Understood, guys? Is it clear? Yes or no?
Okay. I'll repeat again for example.
Okay, no worries. That's what I want your response. If you're not able to understand, you just ask me. That's my job.
Okay.
Repeat it again and again. But if you will not say anything, how do I come to know? Are you able to understand or not?
Okay, sir. Thank you.
So see, client is requesting 04 subfunction. 04 is used to do what? Read snapshot record, right?
Yes, sir. Snapshot record. Okay.
So now, as per the ISO, the request for reading a snapshot record will be of 6 bytes. Okay.
Okay.
As per the standard document 14229, the request should be of 6 bytes. Here, the first byte is 19 service record. Okay, so service ID, which is read TTC information. Clear? 04 is subfunction, which is used to read snapshot record.
Yes, sir.
And after 04, there should be DTC mask, client defined DTC mask, for which DTC client wants to read that information. See, for each DTC, if let's say for this DTC, 01 snapshot is there. Okay, if this DTC is logged, for this separate 01 information will be stored, and for this DTC, separate 01 information will be stored. Understood? For each DTC, there will be separate snapshot will be stored in the memory. It's not like for this DTC and this DTC, both same snapshot will be stored. Because when this DTC was logged, at that time vehicle speed can be 30 or 120 kilometer per hour. But when this DTC was logged, at that time vehicle speed is 80 kilometer per hour. Understood?
Yes, sir. Yes, sir. Got it.
So for all the DTC which are stored, there will be separate snapshot record will be stored in the memory. So that's why we need to, client has to request for which DTC client want to read a snapshot record. So it will do using a snapshot, client defined DTC mask. So we'll send client wants to read for this DTC. Okay. Now for this DTC, we have two snapshot identification. So client has to be specific whether it wants to read snapshot 1 or snapshot 2 data. Does client intended to read vehicle speed, ECU temperature, ECU current, engine speed information, or it is intended to read snapshot 2 which contain column velocity, driver torque, brake demand, yaw rate information. Understood? That will be in this.
Okay. Okay, sir. Thank you.
So here, if you want to read 01, it will send 01. If you want to read 02, it will send 02. If it is sending, client is sending FF, then after receiving, server will come to know whatever this snapshot record identification is implemented for this DTC. Client wants to retrieve all. This means all snapshot. Understood? If let's say for this DTC, one more snapshot is there, 0A. So all three client has requested. If the client has requested for FF. Is it clear?
Yes, sir. Clear.
Okay. So now, after receiving the request, server will retrieve the data and will transmit as per the positive response. So 5904 DTC number 789A BC. Then status of this DTC. Let's say status of this DTC is 24. Okay. Followed by snapshot record. Understood?
Yes,
And
sir.
snapshot record.
It's got it.
Snapshot record will be with DID number. DID of vehicle speed, then vehicle speed information. DID of ECU temperature with ECU temperature information. DID of ECU current with ECU current value. Understood?
Yes, sir. Got it.
Everyone, is it clear? Clear now? So now likewise for extended data record, there can be multiple extended data record. Let's say it can be 01,